So the left-handed people have a mean of 59. So again, kind of estimate where that is. This is gonna be really hard here in the middle because these are gonna get really tight because we got a 91 and a 95 and a 99. So actually that should be even closer than that. And then out here at 240. Okay. Not looking good for the home team there. 42. So we got the minimum down here at 42. 73.5 is going to be quartile 1. 103 is my median. 193 is that. And then we're going to jump it up to 348. All right. So again, when we go to do our assumptions, I have two skewed right sets of data. So and typically with anything that you time, it's going to be rough as far as it's going to be. It's hard to be fast, but easy to be slow. So they're always typically skewed right. But I was going to make another comment there, but I forgot. Anyway, it doesn't matter. Actually, in reality, we were good with the right-handed people because we had 31, so we could go approximately normal there, but we only had 6 left-handed people. So we needed a larger sample to do that. So anyway, that's what we're going to compare for that. And to make my life easier, I need to jot some numbers down real fast. Otherwise, I'll have to keep flipping back and forth. Okay. So we're going to perform an analysis. We're going to hypothesis test, and it looks like I forgot to go back and change the second page of this because we used to do males and females, and that helped us balance out the numbers as far as in each group. But I decided we did males and females for something else. I can't remember what it was. What other activity did we do? I don't think I skipped it with you guys because it was too hard. It was something. It was cup. Oh, the cup stacking. No, I didn't. We did it. It goes the cup stacking activity. All right, I'm losing my mind. Here we go. Our null hypothesis again. So this is what happens is we're gonna create a 2-sample t-test. Get in a groove here. Okay, so this 2-sample t-test again we haven't done the notes. Maybe we should have done the notes first, but it doesn't matter. We're gonna have that so one of two things. Either the mean of my left-handed is going to equal the mean of my right-handed. That would be one way to write that. Or again, it's the mean of left minus the mean of right is equal to 0, because that's essentially what we're doing is we're going to see how close that is to 0. Now we just want to see, is there a difference in the mean amount of time taken? And this is for left and this is for right. So in that case, my alternate could be the mean of left is not equal to the mean of right. So we've essentially turned this into a 2-tailed test, which is going to be double my area. So it's going to be a little bit harder to reject that null hypothesis, but we'll see where it goes. In this case, also, we'll write this as the mean of left minus the mean of right is going to be not equal to 0. Okay, so that's what we're after here is 2 samples. We're going to check our assumptions. Number 1 is we had a random sample. Of AP Stat students. We'll make that our population. And that will be a frowny face. Number 2 was it was approximately normal. Box plot's not symmetric. We get our second frowny face. 3 is again independent. And 6 is less than 10% of actually in this case, we tried to do we're not sampling here. We actually tried to do entire population, but it is what it is. Oh, well, if we refer to that as my population, I could have done my high school students, and then I'd have been okay. But we'll give ourselves the frowny face. This is more about the mechanics. So name a test. So this is going to be a 2-sample t-test. Okay. It asks us to calculate that test statistic. Okay. So again, it's going to be the difference in something. So if we go up here to, we observed a difference of, and again, this is where it comes, might need my notes here. 113.17 minus 136.45. So that is the observed difference. I'm expecting a difference of 0. In reality, again, that makes no never mind, because minus 0 is still just going to be 0. Okay, and now I need that standard deviation adjustment here in my denominator. Okay, so I actually don't know what that is off the top of my head. So we're gonna jump back out and find somewhere. We're going to find a formula sheet. Okay, and we're going for the two populations again. So where to find this at? We have proportions and we have means. We're not pooling our data. So up here is my proportions, but it's still exactly the same thing. We have observed minus expected divided by my sample standard deviation. So it's all running very similar to what we're doing. I just need to find out what is my adjustment for my standard deviation. Here, this is showing me populations, and in reality, I have samples. So I'm going to be over here with this guy here, but it's still the same thing. I'm taking and squaring my standard deviation divided by my population sample size. If I could not try to talk so fast. So anyway, back to this. We were trying to fill out my maze activity. So we have the standard deviation of 113.17 squared divided by my sample size of 6 plus, and again, even though we're doing the difference between these two means, we're still, except I wrote down a mean, that wasn't any good. We need a standard deviation. And in any regard, we probably are not headed out to do that at all. As far as I'm not going to make us type that in our calculator, because our calculator does all the other stuff for us. So let's, sorry. I'll flip back and forth too many times. There's my calculator. All right, so again, we're going to go into stats. We're going to go over to tests. I have a 2-sample t-test, so in my case, it's an option 4. I actually have the data, but I didn't share that with you, so now we're going to have to go over to stats. So here we have 2 means and 2 standard deviations. So mean number 1 was 113.17. Oh my gosh. Oh, that was right. Okay, never mind. Gee, Merry Christmas. My standard deviation was 63.86. My sample size was 6. Mean number 2 was 136.45. We're going to clear that. 83.16. And a sample size of 31. We decided we were doing not equal to. We're not going to get in the pool, and we're going to calculate. Okay. So the stuff that we need, and I'll write that down too. It tells me what my test statistic is. It's a negative 0.7572, which is way more deeper than I needed to go. We also have a p-value of 0.469. So unless let's see here, double check these. 113.1, actually, well, I see that my first mean I entered wrong or incorrectly. I just entered 113.7. It's actually this is not going to make a difference in my test. I just wanted to get more exact answers. So I got to go back to stat, calculate. All right. And everything else remains the same. So how much did that change? Probably nothing. 7748. It changed it a little bit. There it is. Okay. So now we're back out here. We got our test statistic that t was a negative 0.77. We obtained a p-value that equaled 0.459. So now we get to make a decision. Nowhere did it tell me any significance level. So my significance level, we're going to list at 0.05. So again, our decision, since our p-value is less than alpha, we will fail to reject the null. Except, man, it is Monday morning. Is my p-value really less than alpha? My gosh. Somebody stop me out there. You're all asleep? All right, p-value is greater than alpha. We'll fail to reject the null hypothesis. There is insufficient evidence to suggest left or right-handed people are quicker at getting through mazes, or there's a difference in their speed to get through mazes. Okay. So in part 2, it wanted us to construct a 95% confidence interval for the difference between male and female's time. So we'll just do that real fast. We won't do the mechanics of it. We'll just go to our calculator and write down the interval. I mean, technically we could go, well, okay, sorry. Well, we can go through panic if we need to, because we've already done the parameters, because we established, oh my gosh, man, okay. Somebody just start screaming at me, Mr. Dottie, you are stinking it up today. This is all on video, or I'm recording this all too. I'm going to re-record myself to avoid all this. I committed the cardinal crime of not defining my variables up here. Oh, so mean L is the true mean time for left-handed people to complete maze. Mean right. Oh, I am. Sorry, didn't mean to scroll through that fast. Okay, so again, we needed to define some variables, which we got done there. So our parameters are defined for number 2, except our confidence interval, we're actually going to do a difference between two means there. So in this case, it really was a true difference. Our assumptions were done from up above. Did we name it? Man, that's horrible. So this is going to be a 2 sample t interval. We'll go ahead and use our calculator out here. So stats, we'll go over to calculate, except now we're going to do that 2 sample t interval. Again, we're using a t interval because we do not know the population standard deviation. And hopefully this stuff all just carried over, so I don't have to re-enter it all. And it looks like I'm there, except it's 90% confident. Did I have the right confidence level set on the other one? My gosh, is it really? It is Monday, isn't it? How confident were we supposed to be? Okay. Wow. Driving the struggle bus today. Champing it. I forgot what we're after. 2 sample t interval. Everything stayed in there from the other example. Since our alpha level was supposed to be what, 95% confident? Oh man, what did it tell us to do?
95%.
Thank you. Okay. So we ended up with a negative 91 to a positive negative 91 to a positive 45. We'll just round off in there a second. So negative 92 to a positive 45. And I'm not worried about writing out the conclusion today. It just wants to know, explain how the confidence interval gives the same conclusion. So again, we could have done the same thing. 0 was in the middle of our intervals, so therefore we came to the same conclusion. Because 0 is in the interval. Okay. All right, so we'll back out of this. We'll jump over into our notes key, wherever our notes key is at. We have one more problem to finish and walk through. Actually, we're going to repeat this because it looks like we're going to do the interval for there. And then we have to tell between, it's really, the question is it a 2 sample t-test or is it going to be a matched pairs t-test? Because they look very similar. So we'll talk about how we're going to go through and look at those. So we actually kind of wrote this down on the other page. This is mean 1 equals mean 2, or we're talking about the mean 1 minus mean 2 is set equal to 0. So those are the two ways that I can write this. So alternately, that means that mean 1 is greater than mean 2. Mean 1 is less than mean 2, or mean 1 is not equal to mean 2, which was what we did. The alternate way of writing it is going to, again, be mean 1 minus mean 2 is greater than 0, because all we did was subtract. All we did was subtract that mean 2 to the other side. This one's going to be mean 1 minus mean 2 is less than 0. And this one's mean 1 minus mean 2 is not equal to 0. Okay. Does increasing the amount of calcium in our diet reduce blood pressure? Examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for Black men. Such observational studies do not establish causation. Researchers therefore designed a randomized comparative experiment. The subjects were 21 healthy Black men who volunteered to take part in the experiment. They were randomly assigned to 2 groups. 10 of the men received a calcium supplement for 12 weeks. So we have 2 groups, one receiving the calcium supplement, the other not. So, and actually we have that down here, down below. So N for my calcium group is going to be how many? 10. And N for my placebo group is going to be 11. The experiment was double-blind. The response variable is the decrease in systolic blood pressure, or the top number between the pre and the post, per subject after 12 weeks in millimeters of mercury. An increase appears as a negative number. Okay, so again, blood pressure actually increased for person number 2 here because that is a -4. Okay, because we're going original and post. All right. And again, I wasn't necessarily prepared for this because if I was prepared, I'd have had this all dropped into my calculator so you wouldn't have to watch me enter data, but that would not be the case. So we are stuck. Okay. Anyway, so we're going to do a 2-sample t-test. And again, we could be rolling with our phantoms. I've just kind of started going with the name first because in reality, that's what we'll choose. We'll choose the procedure first, a 2-sample t-test. Okay. In order to do that 2-sample t-test, we're going to need some assumptions. And here again, we have to be careful. This is going to be a not necessarily a random sample or random selection. This is a random assignment. Okay, so do make sure we notice that. Of black men to calcium and placebo groups. Approximately normal. Well, I guess that should have required me to drop my data in there. We got to go look at those box plots. So we'll leave that one alone for now. And 3, again, we don't need that third one because we have an experiment. We don't need independent. So to save myself room, I'm not even going to write it. All right, so my assumptions are there. Actually, I don't know if they're met yet. So let's go ahead and get that data into my calculator. So I apologize. It'll watch me enter data. And I wish I remember if I needed any of this data. So I guess I'll cry a river if I needed it. All right, there's 10. We'll hope I entered those correctly, and I did not because I don't have 2 1s in a row. So how'd that goof up? -5, a 1, followed by a 10, followed by an 11 by a -2. Okay. Okay, I think we're looking good. So let's go plot these and see what we got. So plot number 1 is a box plot, except we'll steer it to L1. I can turn both plots on at the same time, so I have them graphed at the same time. That's a box plot pointed towards L2, so I'm ready to hit zoom and stat. And so there are my two box plots. Again, I've got that skewness to the right that is not looking very pretty, but we'll always take it. So we have a calcium box plot and a placebo box plot. Box plots roughly symmetric. All right, so our assumptions have been met. We need some hypotheses. Okay. My null hypothesis is that the mean of the calcium group equals the mean of my placebo group. We'll write it like that this time. My alternate hypothesis, we are trying to determine if the mean of my calcium group, we want to see if calcium lessens that. So that means that we're going to see a bigger decrease in that. So again, it's figuring out how that compares calcium to placebo. So, and again, because we're measuring the difference in blood pressure, we want to see if my calcium group has a larger average difference than my placebo group. And then we have to define all these. Okay. So there's that. I don't know if I'm moving too fast, too slow, or either, so I will hold up. We do have some summaries. So this is a case of where I'll go out and I don't know what I'll do. I guess it's time to go ahead and run that test. I know we need a test statistic, so we will still just flip out here and use my calculator. So stats, we're going to go over to tests. Again, we're doing a 2-sample t-test, which is option number 4 here. Here we actually have data to do it from, so I'm going to hit data. It is stored in L1 and L2. Again, I don't know why isn't this going anywhere? Is it frozen? So that's not set up right. We're attempting to be greater than. Do not know why it continues to give me an error message. Okay. So it's irrelevant unless, you know, I don't know why we're getting this message. I have all this from my notes, so we're just going to write it down here. We have the mean of my calcium group is going to be 8 points, is going to be 5. The standard deviation of my calcium group is going to be 8.74. And the degrees of freedom is going to be 9. In my placebo group, that mean turned out to be a negative 0.23. The standard deviation of my placebo group turned out to be 5.9. And it had a degree of freedom of 10. So I'm asking you for one last test to write out a test statistic. So that means that my test statistic is going to be 5 minus a negative 0.23. That is going to be mean 1 minus mean 2, or the calcium mean minus the placebo mean. I don't need a 0 in there, or I don't need the equal sign in there. So I'm expecting a difference of 0 divided by my standard deviation, which is going to be 8.74 squared divided by 10, and then 5.9 squared divided by 11. And if I could have ever got my calculator to work, we'd have had a t statistic of 1.604, which generates a p-value of 0.064. So we have named hypotheses, we have defined our parameters, we have found a test statistic, we've obtained a p-value, we need to make a decision. And again, since our p-value is greater than our alpha level, did we define what our alpha level was? We did, or it defined it for us, we're good. We will fail to reject HO. There is insufficient evidence to suggest calcium lowers blood pressure. Okay. This is a very similar to one we did on the when we did the maze activity. As far as now, we're wanting to construct a t interval for this. However, the difference is on the other one, we were just seeing if they're not equal. On this one's actually a one-tailed test. On the other one, we're going to use a 90% confidence level with that. So that way, again, my alpha level is going to be 5% on each side. Anyway, if we follow our panic, my parameters are above, my assumptions are above. We'll go ahead and write this one out as far as just practice writing an interval. We're observing 5 minus a negative 0.23. Again, all I did was pull my means from up here. So all we did was we have all of this data here is what we're pulling from. Plus or minus. Again, our critical value, we would need to use, again, just to refresh on doing an interval, we got to figure out what that critical t value is. So that means that we're going to inverse t, 0.05 and 9, and that's going to give me a 1.83. So maybe this is a nice refresher. And there's that standard deviation again. So I don't know, maybe there's a bad piece of data. We'll try to do an interval and see if we crash and burn on an interval as well. But let's pop out to my calculator. We're going to go stats. We're going to go over to tests. We're doing a 2 sample t interval. Wherever that is at. My big fat fingers aren't hitting the buttons right. There's our 2 sample t interval. I have data. My data is stored in L1 and L2. We're going to be 95% confident. No, we're not. We're going to be 90% confident. I got an error again. There's got to be something bad in my list. That's the only way I can figure that goes. Did I hit a minus sign versus a negative sign somewhere? Oh, well, we're not going to take time to figure this out. There's no sense in burning up that time for you guys. So this is a negative 0.477 to an 11.02. So again, that verified 0 is not in the interval.
It is, I think.
0 is the interval. So yes, that's me getting in a hurry. 0 is in the interval, so same conclusion of no difference. Can be suggested. All right, I'm not doing a very good job today. Here we go. The problem is if I scroll back and look at this, here it looks like I have 2 sets of data, okay? And this came from 2 specific samples. Even though I had 1 sample of men, I broke them up into 2 different groups, so I had 2 samples. If I scroll back and I look at my golfing test, okay, I took a set of 9 professional golfers, okay, and we had them hit a Titleist and we had them hit a Callaway. So therefore I had 1 sample, but I had 2 different results from the same sample because I gave each individual both. So when we're trying to determine that, but it still looks like I have 2 lists of data. So the problem is determining, is this a matched pairs t-test or is this a 2 sample t-test? And so this is what the last page of notes is going through, is how to tell the difference between the 2. Okay. It's do I have a 2 sample t-test or do I have a matched pairs t-test? Okay. So basically we look at it like this, and I don't know, this isn't written up there very good at all. Is it 1 sample with 2 variables, or is it 2 samples and 1 variable? So if we look at number 1, to test the effectiveness of 2 leather conditioners, brand A and brand B, they will be applied to a pair of leather boots. One brand is applied to the right boot while the other is applied to the left boot. Which boot receives which treatment is determined by flipping a coin. So this is the same individual, but we're going to have 2 different variables on the same set of feet. So that means this is going to be a matched pairs, okay? Mrs. Sapp is interested in whether playing Friendo during school decreases productivity. 20 MHS students agree to participate in a study to investigate the question. Mrs. Sapp readily assigns 10 students to taking notes while playing Friendo, the other 10 to take notes without Friendo. So again, because we have 10 students in this group and we have 10 students in this group, this is going to be 2 samples. So that means we're going to take a 2 sample T. There's also random assignment of groups. Some students claim they have improved focus if they drink in their if focus in class, if caffeine is in their system. We'd like to examine whether drinking a can of Mountain Dew or drinking a cup of coffee has the same impact on focus. We take a random sample of 20 students and have each student drink a can of Mountain Dew and then take a test. On another day, the student drinks a cup of coffee and then takes a test. We randomly determine which treatment is given first. We then compare the results. Okay. So we took our 20 students. On one day, the student drank the cup of coffee, and then the next day they did a Mountain Dew, or vice versa. So again, we took these same 20 students. On one day they did Mountain Dew. On the next day they did coffee. So because it was the same 20 and we just did Mountain Dew and coffee, this is going to be matched pairs. Because each subject got both treatments. And in the second part, again, we take the random sample of 40 students and have them drink a can of Mountain Dew, the other half drink coffee, and then give each the 40 students a test and compare results. So because I had 20 students taking Mountain Dew, the other 20 were taking coffee, this is our 2-sample t-test. So I had the 2 different samples. All right. We have matriculated our way through the notes. I'm going to stop my screen share here shortly. I'll just stop it now. Okay. So it looks, I mean, basically we have the homework due. There's a bell work due. I think I have the bell work in the module. I'll go double check that here. Actually, I'll just look at it now while I'm talking, even though I'm not very good at talking and trying to do something else at the same time. Anyway, we're done with that. So the homework that's going to be due is you're going to have the note packet and homework packet. It's actually all 1 grade for this particular chapter. So there's no sets individuals. So it's the whole entire thing because it's fairly short. And then on Thursday, actually, that'd be Wednesday, I'll open up the test for you. 7B bell work, there it is. So the bell work and the homework and the notes are all going to be due probably Thursday, I think, Thursday. And then we have a test to take Wednesday or Thursday. I'll open it up for you on Wednesday. Wednesday will just be a check-in day, so I'll open it up at 7:40, and between 7:40 and 8 o'clock, just check in with me, and we'll do our usual check-in since it's a test day, and I have nothing specific for you. Actually, I can stop recording because we don't need to see this.